Okay, so today we're going to cover chapter 4. What we've done is we've pulled out important topics from chapter 4, and we're just going to do a quick review because majority of the information provided in chapter 4 is a pre-algebra skill that you probably have seen multiple times before. But we're going to review it because it does show up on standardized tests. So the first thing we're going to talk about are the two different types of transformations. You have rigid versus non-rigid transformations. And a transformation is just a function that is going to move or change a figure in some way to produce a new figure. Whenever you see the word image referred to in this chapter, they're talking about the new figure. The pre-image would be the original figure. When we refer to rigid motions, we're talking about transformations that are not going to change the shape or the size of the figure being moved. Non-rigid is going to change the size and the dimensions of the shape. We're only going to be focusing on the rigid motions. The non-rigid could be an example, would be a dilation. And if you think about when you go to the eye doctor, if you've ever had your eyes examined, a lot of times what they'll do is they'll dilate your eyes. And what that does is it enlarges your pupil so the eye doctor could look into your eye to make sure that there's no eye diseases. So a non-rigid motion could be a dilation, and it could be either a reduction, making it smaller, or an enlargement. Now we're going to talk about the three types of rigid motions that we're going to talk about. And the first one is called a translation. And a translation is also known as a slide. And we're either going to be translating it vertically or horizontally. When I would teach this to middle school students, I would tell them, notice the word translation has the letters SL in it, indicating that that's my little hint that when you see the word translation, it's a slide. And what's going to happen is they're going to give you a rule. And you're going to be given order pairs of your original shape. And then they're going to tell you some kind of movement to each of the order pairs. So for example, your X will either have something added or subtracted to it, and so will your Y. So for example, if there is a number that is subtracted from X, this is going to be a translation to the left, whatever the number is. So if it were X minus 4, that would have been 4 units to the left. If the X has something added to it, that will be a shift to the right. These are the horizontal shifts. When you have your Y coordinate, if something is subtracted from it, this will be moving the order pair down, whatever the number of units is. And then when it's added, it will be a vertical shift up. So for example, let's say I said, take your original order pair, X and Y, and I want you to do X plus 4 and Y minus 1. The plus 4 would tell me I would be shifting it 4 units to the right. And then the minus 1 would be 1 unit down. So you'll be given some type of rule of what they expect you to do to each part of the ordered pair. So this would be a slide. The next one is a reflection. Notice in the word reflection, I have the two letters FL. So this is like a flip. And they're going to tell you which line to reflect it across. A lot of times they'll tell you to reflect it across the x-axis or across the y-axis. Or sometimes it will just be an equation of the line, like y equals x or y equals negative x. And if that's the case, There are some rules that you can memorize. They're right here in this tiny little print. So if it's reflected across the x-axis, notice the x of the ordered pair, and here they're using the letters A and B. When it's reflected across x, the x of the ordered pair stays the same, but the y changes to opposite. When it's reflected across the y-axis, the y stays the same, but the x goes to the opposite sign. And then if it's reflected across that diagonal line of y equals x, then the order of the ordered pair switches. The y becomes the x and the x becomes the y. And then if it's reflected across the line y equals negative x, you switch the order and the sign. Now what's nice about the reflection, if you have the original ordered pairs graphed and you have the line of reflection, you can also just count the spaces away that the figure is graphed from that line of reflection. And let me show you what I mean by that in the example that's provided here. So notice here, I've got my line of reflection is this green line, and I'm going to highlight it, go over it in purple. This is my line of reflection. My original figure is the blue. Now, let's say I didn't memorize, in this case, the line that it's being reflected across is the line y equals 1. So what I can do to get my new reflected ordered pairs, notice the ordered pair A up here is the ordered pair 3, positive 1. Notice that this ordered pair is 2 spaces away from my line of reflection. So to get the new A ordered pair, I'm going to just count 2 spaces away, and then my new ordered pair for A, and then to indicate the difference between ordered pair A and the newly reflected one, they put a little apostrophe. It's called a prime mark. So it's A prime, and that new ordered pair would be 1, negative 1. It's actually been the same number of spaces away from the line of reflection. We can do the same thing for the B. This order here for the B is going to be the order pair 5, 2, but my reflected one, notice it's 1 space away, so I can go 1 space away here to get my B prime, which is 5, 0. Notice that the order pair for C was on the line of reflection, so this is going to be the same for the original as well as for the reflective. So that order pair is the order pair 2, 1. So it's the same for both when one of the order pairs is on the line of reflection. So for the reflection, you can either memorize the rules or just count how many spaces away it is from that line of reflection. The rotation, you're going to want to memorize the rules. My original A was 2 spaces away on top of the line. So my new A is going to be 2 spaces below it. So it's like I flipped it over, and it's got to be the same number of spaces away. Here's my x-axis. The black line is the x-axis.
Oh.
You see that?
Yeah.
For the rotation, this one, if you notice, this one doesn't have like an SL or an FL, but it's got 2 T's in it. So I think of this as like a turn. So I'm actually rotating my figure either 90 degrees, 180, or 270. So for these, it's easier if you remember the rules. Now, any of these 3 that are here could be combined together. You don't necessarily just have to do a slide or a reflect. You could actually do a slide and a reflection all with the same figure. So you can do multiple transformations with one figure. So let's go ahead and let's do some examples. So the first one, notice this looks like a mirrored image, and the blue one is the original, and the red one will be the new one. Now, just to keep with the same naming, let's call E, this will be my A, actually let's call the E is going to be my B prime, because this is going to be the new B, and this is going to be my new A, and then this is my new C, just to keep with the same naming here. So because it's being reflected across the y-axis, and let me do it in highlight. So this is my line of reflection. I can count the spaces away. So notice A here is going to be 2 spaces away from my line of reflection. So my new A, which is in this picture called D, is 2 spaces away as well. Now, you can also memorize the rules. When it's reflected across the y-axis, the rule, what you do is you take the order pair, AB, and the newly reflected one, what stays the same as the Y, but the X goes to opposite. So my original A was the order pair -2, -1. My reflected A, which in this picture they called it D, is going to be opposite of X, but Y stays the same. So the line that you're reflecting it across, that order pair stays the same. Now for B, my original B is the order pair -1, -1. So again, my new B, and in this particular case, it's the E, I'm going to change X to opposite, Y stays the same. For C, -2, -3, or -5, sorry. And then the new C, in this case it's F, X is opposite, Y the same. So again, we can just apply the rule if you know the rule. If you don't know the rule for the y-axis reflection, then just count the spaces away. Each of the original order pairs are, and then graph the new one on the other side of the y-axis. All right, so for number 2, I'm going to go ahead and write down my order pairs, and I'm going to see how they changed. So my original M is the order pair, let me do L first, sorry. Let me do this alphabetical order. So I'm going to do L, 1, -1, and then the L prime, the new L, is the order pair -4, +1. So if I look to see what happened to the 1, it looks like what they did to get the new one, the L prime, it looks like they subtracted 5 from the X and added 2 to the Y. So that's how they get -4, +1. And you could have counted the spaces. So let's do that. So to go 1, 2, 3, 4, 5, since we're moving to the left to get to the new L, that's why it's subtract 5. And then they moved 1, 2 up, and that's why it's add 2. So my rule here is take X, subtract 5, take Y, add 2. So again, the -5, this is going to be 5 to the left, and the +2, this means up 2. So now the next order pair, M, the original was 4, 1. And then to practice to see, we would subtract 5, add 2, and we get -1, +3. And we can confirm that that's what the order pair was that was graphed. And then lastly, the N, the original was 5, -1. Again, apply the rule, subtract 5, add 2 to the Y. So 0, 1, and that's what's graphed there. So this one was a translation, and it slid from over to the left and up 2 units. You didn't necessarily have to count the spaces from L to L prime. You could have done M to M prime or even N to N prime. You can even just take the coordinates and look to see if you've written down what the order pairs are. But if you've got a graph, it's easy to count them. All right, so for the next one, this figure has been turned or rotated. So this is actually a 270-degree rotation about the origin. So when it looks like they've turned it around, know that that's going to be a rotation. So for the 270 rotation, your original order pair is AB. And when they change it, when it's 270, the order switches and the X goes to opposite. In this case, we're using the letter A. So let me go ahead and write down my original order pairs. R was the order pair 3, 1. S was the order pair 5, 1. T was the order pair 5, negative 3. And U was 2, negative 1. So my R prime, again, we're going to switch the order and then make the X the opposite. For the S prime, 1, negative 5. T prime, negative 3, negative 5. And the U prime, negative 1, negative 2. So they switched the order and then the X coordinate went opposite. And this would have been a 270-degree rotation where they rotated or turned the figure. Okay, so for the first one, again, all of the same original order pairs, but they want us to slide the first one, reflect or flip the second time, and then rotate or turn the third time. So for the first one, I'm going to go ahead and write down P, Q, and R. I'm going to do them, the originals in blue, P, Q, R. So the original P is negative 2, 3. Q was 1, 2. And R is 3, negative 1. So I'm going to take to each one of these order pairs, all the X's, I'm adding 4 to get my new order pair. And all the Y's, I'm subtracting 2. You apply the same rule to every order pair. So my P prime, or my new order pair here, is going to be 2, 1. The new Q, 5, 0. The new R, 7, negative 3. And now on the next slide, I'm going to graph these in a minute. But let me go ahead and figure out all the new order pairs for the 3 questions. So again, I'm going to write my originals again. P, negative 2, 3. Q, 1, 2. R, 3, negative 1. Now remember, whenever you reflect something across the x-axis, the original order pair, and then reflection across x, x stays the same, because that's what we're reflecting it across, and then the y goes opposite. So my new order pair for P, X stays the same, Y is opposite. The new Q, X stays the same, Y opposite. The new order pair for R, X the same, Y opposite. Now again, if you just graph the original, let's say you forgot the rule for the reflections, graph the original, count the number of spaces that P is away from the x-axis, and Q, and so on, and that's how you can graph your new ones as well. And then the last one, the 180 degree, remember this one's easy. You take your original, and then it stays in the same order, but just make both of them opposite signs. So this is the 180. Again, to show the original, negative 2, 3. 1, 2, 3, negative 1. So now when I rotate it, my new P prime, same order, opposite signs. Same thing here, Q. They both become negative now. And then the R, 3 becomes negative, and -1 becomes positive. So if you know the rules, coming up with the new order pairs makes it easier. Again, think of the 180 as like a double turn, a quarter of a turn, which would be 90, and then a half turn would be the 180. Now let's go ahead and just take all of these order pairs and graph them on the next slide where I provided the coordinate plane. All right, so for number 1, remember this one was the translation or the slide. This one is a translation. In other words, it's a slide, and again, it's got SL in it, and it tries to write the word slide. So I'm going to rewrite. Okay, so for this one, remember the rule was add 4, subtract 2. So my original order pairs again, -2, +3, 1, 2, 3, -1. And they had asked us to add 4 and subtract 2. And it's the same rule for everything. So the new P, remember, was 2, 1. The new Q was 5, 0. And the new R was 7, -3. So now I'm going to graph these 6 order pairs. So I'm going to graph P first. It's at -2, +3. Then I'm going to graph Q. It's at 1, 2. Then the R at 3, -1. I can go ahead and connect and make your skinny little triangle here. And now I'm going to graph the new one. Now this one was the slide. So we've shifted it to the right 4 and then down 2. So the new P prime is right here, 2, 1. Then Q is 5, 0. And then the R is 7, -3. So again, connect. And you can see how it was shifted over to the right 4 units. And then they shifted them all down, all 3 order pairs, down 2 units. And this is a translation or a slide. Number 2, remember, was a reflection. And they asked us to reflect it across the x-axis. So again, remember your order pairs originally. -2, 3. Q was 1, 2. And R was 3, -1. So remember on this one, the order pair, the X stayed the same and the Y went to opposite. So my new order pair for P prime turned into -2, -3. Q became 1, -2, and the R prime became 3, 1. So I'm going to graph these order pairs now. So again, if you wanted to copy your blue and then paste, you don't have to keep redoing the blue each time. So there's my P. My Q is at 1, 2. And my R was at 3, -1. Again, connect. And now to show the reflection, my new P prime is at -2, -3. And notice the distance from the x-axis, which is what it was reflected across, was 3 units. And then 3 this way. So again, if you forget the rule, just graph the original and then count how many spaces away it is from your line of reflection. So again, this is my P prime. And then my Q prime is at 1, -2. And my R prime is at 3, 1. And again, I can connect. And this is the reflected image across the x-axis. And then the last one was the rotation of 180 degrees. And again, remember the order pair stayed the same. You just flipped it to opposite. So again, I'm going to graph the originals in blue. Again, P, same exact order pair. Q, 1, 2. R, 3, negative 1. And now the new P prime. We're flipping the signs, same order. Q prime, same order, just make them opposite. And then lastly, R prime, negative 3, 1. Just memorize the rules for these. So let me graph the order pair, negative 2, positive 3, 1, 2, 3, negative 1. Connect them, P, Q, R, and then now the new ones. Positive 2, negative 3, that's the new P prime. Then Q is negative 1, positive 2, or negative 2, that's my Q prime. And then lastly, the R prime, negative 3, positive 1. And connect. And you can see how it looked like it was rotated around the origin. And when it's 180, it looks like it's a flip. So again, your homework is on big ideas. I did post the assignment both on the link to Big Ideas through Canvas as well as Safari. I prefer you use the link through Canvas. However, if it is not working and you're still getting that white screen, go through Safari. This homework is due on Thursday, the day that I will see you again. Again, remember Wednesday is the PSAT. Bring your pencils, your calculator, and your snacks.